Okay, so hello everyone. So this talk is about how to do TDD. It's not about that I'm going to convince you to do TDD. So if you don't like it, it's fine. I just want to show you how to do that. And it's also not about Scala, which description says something about it. So don't pay attention to this. I've given this talk in JavaScript, Ruby, Python, and maybe something else I don't remember. So it doesn't matter the language. Scala will enable us to spot some functional biases that I want to show you today. So this is only a tool, and if you do something with different language, just go that way. Okay, so this is, first of all, who am I? I'm server guild master, whatever it means, at Wix.com. So basically, I work in backend engineering team and occasionally coach people about design and test first techniques and maybe something else. And they also coach me about doing something like engineering in general and so on. I also organize Vilnius Java user group. It's one of the biggest meetups in Vilnius for developers. So if you're a Java developer or you care about general software development, please come and we'll have some fun times. You can follow me on Twitter. So motivation for this talk. I want to show you how rigorously apply test-driven development practices while learning how to do test-driven development. And the big point is here that if you do test-driven development and someone like me says that this is wrong, this is not test-driven development that you're doing, it's fine. Like, just better to do something compared to not to do it at all. So test-driven development is a state of mind. This year, I think this way. Maybe 1 year after, I will tell you, okay, I was wrong in this place because someone from the audience, maybe some of my colleagues or some new project that has taught me something different. I will show you that we can implement algorithms without knowing the actual algorithm. So this is a classical TDD example. It doesn't work all the time, but it works most of the times because test-driven development is about driving your design in the program. And design works pretty nice with algorithms. And the most important thing I want you to remember is about feedback loop. This is how I write one thing in the test, and I want you to see how production code reacts to it. And when you do something in production code, I want you to sense something that maybe there is something wrong with test code. So that's the important part, feedback. Let's recap what is test-driven development. So if someone of you doesn't do that, it's important to understand that there is such a cycle. First step is to write a failing test. And it's really important that you write a failing test, like not compiling or basically showing that there is no such feature. If you start with a passing test, you don't know if that test works. It doesn't prove that you missed some feature. Then you move to second step, which is green phase. And green phase is for writing minimal amount of code to pass the red failing test. So it's important that you write the simplest possible amount of code to pass it. And then important third step is where we are going to concentrate a lot today. It's refactoring and basically refining your test. And refactor is important because we already have test and we have minimal amount of code. So we have a safety net between those two. And while we refactor, we can maintain stability in our source code. And today I will pick a standard kata for test-driven development. It's a Roman numerals. I believe that most of you know. For example, you have seen a watch with Roman numerals where letter I stands for 1, 2 letters I stand for 2, and so on. So just it can be a really complex number, but nothing new here. Okay, so let's go to the code. I will use Scala. but you don't have to know anything about it. If you, for some reason, have some question and it is related to maybe how Scala works, just raise a hand and ask it. If you have some comment about test-driven development, I urge you to maybe leave it for the end of the talk, because I have not enough time to finish the whole exercise. So let's see how it goes. And feel free to catch me after the talk. I really like to talk on the subject. So this is a simple test which just demonstrates that our framework works. I have a rapid feedback loop where if I change something in the code, tests immediately run. So this works very nice with unit tests, where unit tests are just really quick thing to run. Okay, so what we need to do, we need to write a first test. And this is the hardest problem most of the time for even experienced test-driven developers. So what is the first test that we can come up? I usually think that way, that you have a set of requirements and you just sort those requirements according to how complex they are. And you pick the simplest one. So in our case, the simplest one will be something like converse 1 to I. And this should be a very simple test. And for this we don't have any production code. So everything I will write, it will fail immediately. Now one of the hardest part is that I need to give some good names, but this talk is not about naming. Naming requires separate talk, and to me it's the most complicated thing in the world. So let's call it like Roman numerals. Let's have it something like this, to Roman, and it will accept 1, and it should be. By the way, if you see I'm doing something really strange because like I'm on a stage and like it's not my regular environment, help me fix my mistypes, and I really want this feedback from you. It should be I. Okay, so okay, it works for some reason. What am I doing wrong? This is, by the way, why you need to have a failing test. It just it works for some reason. So am I running something in the wrong terminal? No, it's not. Yeah, I have cheats in case I will end up in such situation. So, but let's try to restart it. Okay, Roman numerals. Why does it work? Okay, let's try simple. Okay, let's do something like this. It's not even this test. Oh, finally it works. Maybe I have Roman numerals already somewhere. So let's have converter, because we're not about names, and I will quickly get rid of that. Roman should be something like this, and see if that fails. Okay, finally. It probably means that I have another implementation and it just worked. So what do we do now? We need to basically make this test compile. So I will have a new file. Usually, if I work alone and I start implementation in the same file, but for clarity here, because I cannot fit everything on one screen, and I have I will use separate file from the beginning. But I usually start in the same file and then factor it out to a separate one. Okay, so now I need a method. And it takes, what does it take? Let's say that it takes Arabic. And okay. IntelliJ is too smart these days, like it doesn't help anymore. Okay, so those question marks at the end mean unimplemented. So if you don't have some similar concept in your language, so this is unimplemented, and it will throw, let's see what it throws. So it says implementation is missing. So it's a good feedback. I have a compiling code, but on the runtime it fails. Now what I need to do, I need to come up with implementation. And remember second step. Second step says that it has to be a minimal amount of code. So what is the minimal amount of code? It's just returning I. Yeah, we have a working production code already. So I want to point out that this is really good feedback loop, and already after like spending some hassle sorting out with the environment, I already have working code which supports conversion of of 1 to I. And if you like basically what it means, iteration 1 finished, let's wait for an hour, we can start with 2 or something like this. But it's a quick feedback loop, and you already can demo it to your customer because you know that it's in working state. Okay, I need another test, and another test is just picking another easy requirement. So let's see if we can convert 2 to double I. Okay, I already feel a pain of repeating myself. So if you're bored to watch this, I feel a pain of type this. I'm urged not to copy paste, but copy pasting and like repeating, just retyping is the same thing. It's just like a habit. Convert. Okay. And I will show you how I will get rid of my bad naming, but you don't do this at home. I will just use a simple name for this demo. I probably need to prepare a talk on naming just to prove that I'm not doing this myself. Okay, so what do we do now? First of all, I feel that there is something wrong with my tests already. So many repetition and so little information which is important. But I'm on the rest test phase, so what I need to do, I cannot do refactoring here. I need to move to minimal second step, which is get my code to green stage. And what I need to do, I need to implement something very simple. And being simple is, for example, using if and asking if it's 2, please return double I, else return I, and see if it works. Yeah, it works. Iterations 2 passed, so we can go home now. But remember, this is something wrong. I feel that there is too much duplication here. What we can do, what is really important here? Important bit is this Arabic number and this Roman numeral, this Roman letter. So I really want to put a lot of emphasis and show what is important in my tests. Imagine that I can easily make a mistake somewhere here and some reader will be confused. So I think that we should go and remove duplication here. So let's say that we have examples. I'm calling these examples on purpose so that I communicate to you that this is not something like property-based testing or something. We're doing example-based testing. And if you have heard about property-based testing where you can generate a lot of tests by using some random generators for some test input, so this is not what I'm doing. I'm just like extracting repeated parts. It's like more like parameter-based tests. And parameter-based tests are example tests just in different form. Okay, so I have a sequence which is just a list in Java. So I will say, okay, so our requirements is like this. So 1 should convert to I, and 2 should convert to double I. And then what I will do, I will refactor this part, and I will say, okay, let it be Arabic. Okay, let's maybe start from this. So let's name it examples because it's multiple items already. So I have examples, and for each I will do something. I think in Java it would be really hard to do the same thing. It's because I'm using a different framework, and which lets me to create specs on the fly or tests on the fly. So I will say, okay, in this list, please take each element and assign it to those variables. Arabic, Roman. So this is Scala syntax, but it's not so important. Let's see what happens. I will say converts. I need Arabic number to Roman in, and what I need to do, I should say that convert to Roman. It's really ugly name, right? That convert. I need to fix it. Arabic should be what? Should be Roman. And now I can delete those tests and expect that there will be those tests. What is important here? Let's maybe that we pay the same attention to our test code and remove all important duplication from there. And you may think that this part is really important in your code, but I would say that you should look here in your test report, which says that, okay, this works like this, this works like this, and what is important in the test, that you know that, okay, you have this example, this is your requirement, you have this requirement, and you can, and this is more, it's easier to find in your code base what's important by doing this, because in this case it will be only examples which are from integer to string. If you have different case where you have to do different like tests, don't put them in examples like this. Maybe it doesn't work, but listen to your code. So what is the next test? I need to move, and I need to move. Okay, so we have very little code, and I need to add another rule, and I need to see if it works with 3, for example. So let's see what it says. It doesn't, and I will go and I need to do something here. So what can I do? I can say, okay, an hour. Do you feel a tension already? Like there's tension growing. I even feel that I don't want to do this myself, but I feel that this is very simple code. It's easy to explain what's going on. Okay, so we have this. We have this, and we have. Okay, and it works. Now I'm in a green phase, and I want to get rid of this tension. So what I will do, I will say, okay, I have I, and I will say, let's do it like this. Hope it works. It works. So I did a refactoring in this blue phase, but there is one thing that I'm a bit not so sure. Have you ever heard of like multiplication with strings? I haven't. So, but I will leave it like this. I hope it will not bite us in the future. Okay, now very interesting case. There is a for case. And for brings like, is it the easiest one that we have? I think no. So I will leave this for future. I don't want to deal with something what is complex. I feel that it will ask me to subtract something, and I don't want to do this. So let's go to something what will add something new to our code. Let's say 5. This will add additional letter. And let's see a failing test first. And unfortunately, I still have to press save. If I shouldn't, that would be even like the best feedback. So it doesn't work. So what do? I write an if, where I check if it is 5. By the way, you see there's some magic constants already, like, so there are a lot of signals that something is like really fragile in this code. So I will say, okay, let's let it be, and else let it be like this, and see if it works. And it works. Nice. But can I do something about this code? Probably no. There's not so much repetition. Maybe I can extract some magic constant, but I don't feel any duplication here, and I will stay like this. I need another test. What can it be? 6 or 7? I think it should be 6 because it's simpler. It only concatenates v and diff and I, so it should be simpler than 7, for example, which does also I repetition. Okay, let's quickly implement. Oh, it fails, and what can I do? I can say, okay, if it is greater than or equals than 5, I should do, oh, I need a mutable state. Scala developers should hate since now. Like, I know that I will deal with this in the end, so stay with me. So what do we need? We need remainder. And if remainder, var and val are different in Scala. Usually if you see var in Scala, you don't speak to that person anymore. But suppose that I'm coding alone and no one knows about this. So what I need to do, I need to say that, okay, remainder, oh, I'm mutating something. I will do this, and I also need another var. I need result. This is very big step compared to previous ones. So result is nothing. Okay, I need to do like this. Then I have else. By the way, when I see brackets in if statement, there is also indication that something is wrong. If statements should be such simple expressions that you don't need to put any brackets. So if you have 2 expressions in one block, there's something wrong already. Maybe you should think of extracting it to smaller units. Okay, so now result, and this should be remainder. It's very hard, like now. And let's see if oh, it doesn't work. I forgot to do something. Can try. I don't need this, I think. You can also help me, by the way. Okay, it passes. Cool. Can we do something about this code? Probably not much. It looks ugly, but I have to find another explanation why it's wrong. It's just because I'm biased not to do something in Scala like this, I cannot just go and fix it for that sake. So I need another test, and another test is, okay, what kind of requirements do we have? We have 10, which is next one, which will add another letter to my implementation, so let's have it. and we should have a failing test. And now I need another if, and that if is comparing to 10 and doing what? It will say, okay. I could actually use return statement, but I will not do that because otherwise, like, I will be speaking to myself here. Okay, so I need to do this and add the result like this, new letter. Okay, it passes. Do we have duplication? It looks like duplication, but it's not yet. It's not because we have different Boolean operations here. So let's add another test and see if we can get rid of this duplication by just implementing another requirement. I will say that another requirement could be like 15 for having concatenation of X and V, and it fails. Great. So what can I do now? I hope maybe this works. This is nice. Like, you add one small test and you just change operator and it just works. Cool. Can we do something about this duplication? I think we have to. And what I will do very similar thing that I did in tests, but it's completely different meaning. I will introduce rules abstraction in this code. So let's have rules. I don't know how it spells. Like this? Okay, we can have like okay, so my rules are, what do I have here? I also, do you remember I skipped 9? So this is the same case as with 4. We should not forget to implement it. So if we have 5, it should be 5. If I have, I care about the order. If I have 10, I have X. And okay. And now what I will do, I will take my rules and do the same loop. Oh, no, not for. For is too advanced. For each. Okay, that's case, and I want to destructure our rule, and that rule contains I cannot use Arabic anymore. Failure of naming big, I say number. I'm really good at coming quick with stupid names. Okay, so what can I do? I will use this, and I will do that. By the way, do you feel that we are getting rid of those constants without introducing constants? Like constant abstraction, without giving name to a constant. So maybe we saved something here. Now I need to do Arabic number, and Roman numeral, and expect it works. It still works. Fascinating. Okay, let's not forget to deal with 9. Let's not forget. Actually, I never do this in my source code. What you need to do, you should take a paper and put all the things that you like you cannot do it at once. This is how like all those TDD school teachers teach you. So I think it's better because when you have like something like this, you're biased on the specific test. You should be biased on what functionality is missing in your code. So don't do like this. Like if you add to do, write it in some different form than the actual test. Okay. So what's next? 20. I need to finally close the loop. I don't have anything like easier, like I just need to start repeating the same thing. Okay, it doesn't work. What can we do here? We need to repeat. Okay. I will do this. And let's see if it works. It works. This is important thing. If you follow TDD rigorously, there are multiple transformation rules that you can apply on the go. For example, you should know that if is just a generic version of while. So, and this comes from, it's actually not, it doesn't come from transformation priority premise, but it comes, what I really like about transformation priority premise is that it contains a list of transformations and they are in the same place. Like you don't have to read a lot of books. I'm actually not following all of them in precise order, but it's a good thing to know, and maybe it will work for you. It didn't work in some cases for me, so I'm just trying to pick something what works in some case and something what doesn't work in some case. This was invented by Uncle Bob. Okay, something is... and important thing, the more tests you add, those tests become really specific and your code becomes more generic. And transformation from if to while made our code more generic. So this is the important takeaway. If you apply TDD rigorously, you will get really good generic code. It's not good yet, by the way. Okay, so I feel that I kind of nailed a lot of easy requirements, and I need to go to for case. What do I do then? It's a scary moment. I remember when I did this kata without tests, 4Ks just completely ruined my implementation. So let's do it like this as we were and see if it works. It doesn't. What I will do, I will add 4 here and naively will expect it to pass. See what it does. Oh, it works. Cool. So you see, I delayed implementation of complex rule and almost got it for free. Because as you implement smaller things, it will implement a lot of code base, which later will support implementation of complex one. So it's sometimes good to procrastinate. So just leave it for tomorrow. Maybe you'll not need it. Agile principle number 1. You ain't gonna need it. Okay, now we need to do the same with 9, but you already seen implementation, so it should be very easy. Okay, so we care about the order. So that's 9 is this thing. I actually should learn Roman numerals myself before going to speak about them. And it. Oh, I didn't run failing test. So never do like this. This is worst practices in front of you. Okay, so it works. We see that it converts nice. Now I feel that I kind of have full algorithm implemented. The only thing which is missing that I don't have configuration. This part is like configuration to the algorithm. I don't have rest of the numbers configured, but I think they will follow the same path. So what we can do now, we can maybe think of refactoring. Yay, refactoring time. Okay, so what can we do here? First of all, I want to maybe remove some of mutable state. So what can we do here is say that, okay, we have result. Oh, remember this part? We forgot it. You know why? Because it was a wrong abstraction introduced too early. I told you, string multiplication by integer. What is that? So let's get rid of it. First of all, before I break this one, let's get rid of it. And it will return result. And it should fail now because I'm refactoring. And what should I do? I should say, okay, that's a regular rule. Great. So introducing introducing abstractions too early will lead you to a big mess. So think before, all those imperative statements are really low in abstraction at this point. So they don't force you to do something which is like somewhere declaratively different. Okay, I want to map, and I want to map to something. What is our result? I will have another result here. I will move mutable thing inside, and it will be something like this. Or maybe I can do even something simpler. What it actually does, it checks how many times it fits into a number, like how many times Arabic number fits into remainder. So what is that? It's let's call it times. I'm good at names, so remainder, div, Arabic number. It should be how much times do we have, and then what we need to do, we need to change result. We need to change, oh sorry, remainder. We should say something like this. And what we need to do, we need to say, okay, I have Roman numeral, multiply it by times. It's again this abstraction, but I think in this place this abstraction is perfectly fine, because we have a working algorithm and we just want to add more clarity to it. And what I will do, I will make a string out of this, and I will expect that this, by the way, the last statement in Scala is implicit return statement, so you don't need to specify return statement. So what this does, oh, first of all, let's see if it works. Oh, it passed. So we got rid of one mutable variable, but what's left, it still contains remainder. And the problem with that is that we have a couple of mutable states that we need to maintain to calculate result. And for this, we could use fold, for example, if you're a functional programmer. Because we definitely are not going to leave it as this. If you're a functional programmer, mutable state hurts, and you don't want anyone to see this code if you have written. So what we can do, we can use fold, but fold is so, or reduce, but that's so complicated because we need to maintain multiple states before each loop is happening. So what I can do in functional programming is I can use recursion with accumulation. And accumulation is needed for simple reason, because I need to have tail call optimization, and tail call optimization is very important because it solves that problem that if you have a really deep nesting in recursion, you will exhaust your stack. And to solve this, if you have tail call optimization, the last call to recursion is always at the end of your function, and this way compiler can rewrite it to something which just is loop. So you write a recursion, but compiler thinks this is like, it can transform it to while loop or some other loop which doesn't use stack. So what can we do? Because we don't have enough time, I will use cheats. This is very good. I will take this horrible code. That's a lot. Oops. I will have this one, and I will basically first of all I will get rid of remainder, and I'm copy pasting, and I will explain it to you. First of all, we have tail rec annotation, which tells if your code can be optimized. It doesn't guarantee that compiler will do that, but at least we know that this code is fine to be optimized. This is very big code, and you see that going from imperative sometimes to declarative style or functional style, it may be much harder to grasp what's going on, especially if you have accumulation, which is here like a result, or you have recursion. So this is a hard concept to grasp. It's okay if you're a functional programmer and all the team knows about it, but if you don't, you should think twice if you want to go to this way, because you remember the previous solution was even more concise compared to this one. And with this, I want you to basically, I want you to leave with the thought that think before going one on our way, and I want to say that some biases that we have are basically leading us to some or another implementation, and to early introducing abstraction will cause you to have maybe different implementation, and sometimes that implementation is like doing too much. And I forgot one important part. We didn't finish algorithm, so I'm going to do it. I also have a cheat for that. So first of all, I will do it at once, because that's only configuration. I already have a stable code. I will add rest of the rules as a one step. So you don't need to ping pong. I usually don't do this because I know that I'm not going to change my code. I just need to configure my system. So this is one thing. So I need to add tests. Okay. And you'll see why. I'm adding tests. It's very easy to make this. It doesn't compile. Oh. Okay, what doesn't compile? Aha, line 25. Something like this, huh? Loop rules. It's probably not that important at this stage, because I have only 3 minutes left. So I want to go to question part. And important thing that I didn't finish, that if you are configuring your implementation, you don't have to do tests like one by one for each small addition. You can just you can add that configuration to your tests, and see tests fail. They will say exactly that you have this missing, and you can easily add it to your implementation. And this should work. Like copy pasting never works. That's also on our lesson. So thank you, and question time.
Does anyone have questions? Vilnius Scala, when we always have like a lot of questions.
You can ask it how to do it in JavaScript.
You mentioned that you need to make things on the paper. Just
yes.
Could you elaborate a bit more? What do you mean?
If you put some comments in your code, you already think at that point that, okay, I need a test for which converts to like IV. It may turn out that you don't need exactly this configuration in the test, exactly this test. You may need some requirement which fulfills that. Maybe you will add another test that solves that. So on the paper, you just have a different way to express your thoughts, and maybe you just have a note that, okay, I need to solve some issue, but this issue doesn't exactly need to map to a test. And sometimes it's a good practice that you just make a note and you don't comment your code or something. So it's your choice if you go one on our way, but I find that if I put notes on the paper, it leads usually to better thinking. Like, I'm not biased in the code that I need to add a test, I'm biased from the notes that I need to add a requirement.
Okay, we have time for one more question. Okay, so no more questions.
Just catch me after, like, I really like to talk about many things, so if you're for some, I know that people come after this talk to me and say something that they are like maybe afraid to talk about in public, so.
Okay, so give a round of applause for our speaker.
Thank you.
A small